Yo, 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 yo. All right, guys, absolute value 5.1. And let's get going. So for the absolute value function, we're learning a new function, something we have not learned before. So from as of this point, we've only learned about linear functions. Now we're going to talk about absolute value functions. So now our graphs are not going to make a straight line. So absolute value, these are your absolute value symbols. So we're just going to look at what's called the parent function, which is just the most basic absolute value function, okay, where there's no other numbers involved. So the parent function is just the absolute value of x. Think of it like with a linear function. A linear function, the parent function would just be y equals x, where the slope is 1, the y-intercept is 0. And then we started adding a y-intercept, then we started changing the slope. So we're just going to look at what's called the parent function and just look at what is the absolute value of x, what does that graph look like? When we look at those graphs, we're going to look at what the axis of symmetry is. We're going to look at what the vertex is. So get those definitions down, then we'll talk about them when we start working on these graphs. So in order for us to graph the absolute value function, what we're going to do to start is we're going to make a table. So we are going to make a table and to fill out and see what's going on here. So we're going to pick values for x for this table, and then we're going to plot them on a point when we figure out what our y value is. So I'm going to start at -2 for x. I'll do -1, 0, 1, 2. And I'm going to use these values to plug into x, or the absolute value of x, to figure out what my y value is going to be. So the absolute value of -2 is what I'm trying to find. The absolute value of -1. The absolute value of 0. Absolute value of 1. Absolute value of 2. Now, one thing that we need to remember about absolute value is absolute value is just saying distance from 0, saying how far away is this number from 0. So the absolute value answers are always going to be positive. So the absolute value of -2, well, -2 is 2 away from 0, so the absolute value of -2 is positive 2. So my final point is -2, 2. -1 is positive 1. 0 is, it's on 0, so it's 0 away from 0. Absolute value of 1, that's 1 away from 0. Absolute value of 2 is 2 away from 0. So absolute value, all of our answers are positive because it's just a distance from 0. So this gives me the point of -1, 1, 0, 0. So we're going to be at the origin, 1, 1, 2, 2. So let's graph these points and see what they look like. I got -2, positive 2, -1, positive 1, 0, 0, 1, 1, 2, 2. So if I look here, this graph makes the shape. Oh, it was a great line all up until the very end. It makes the shape of a V if I connect the points. So it makes the shape of a V. Now, this is the parent function of the absolute value function. So absolute value of x, without adding anything or doing anything, we're going to start at the origin, and then it's going to make the shape of a V. So absolute value functions will make a shape of a V every time. Now, the vertex is this point right here. This is that center point that splits the V in half. So this one has a vertex of 0, 0. The axis of symmetry is the vertical line that goes through the vertex. Think of the axis of symmetry like a mirror. So the left side is a reflection of the right side. Okay, so this is a reflection of the right side. So this is my axis of symmetry. So my axis of symmetry is the line x equals 0. It's whatever the x value is in the vertex. My vertex here is 0, 0. And then my axis of symmetry is the vertical line of x equals 0. I'm just going to call that AOS for right now. Now, also with absolute value functions, we're going to have domain and range. So if we recall when we learned about domain and range before, domain is all of the x values that are possible for the function, and range is all of the y values. Well, for absolute value of x, I can use any x value. There's no restriction on that. This goes on forever this way. This goes on forever this way. So my domain is just all real numbers. Because all the x values are possible. The range, however, is saying all the possible y values. Well, this will never go negative. This v is going to go up this direction. It's going to go up this direction. So my range is y has to be greater than or equal to 0. Y can be 0, but it has to be greater than or equal to 0. So that's my range. And that's that. So this is the parent function of the absolute value function. So what we're going to do from here is we're going to change this v a little bit and see, we're going to add some numbers to our function and see how this v is changed, how it's manipulated. So now what we have is we have 2 on the outside of the absolute value function times the absolute value of x. So this is multiplication. So I want to figure out, what is this 2 going to do to that parent function? What is the 2 going to do to the v? So what I'll do actually is I'm going to graph our parent function real quick. This is what it looked like. You do not have to do this, but this is just good for you to see. So this is what we just graphed on before. That's the parent function absolute value of x. So now in purple, we're going to graph the absolute value of 2 times the absolute value of x. And we'll use the same points. We'll use -2, -1, 0, 1, 2, and see what happens. So 2 times the absolute value of -2, 2 times the absolute value of -1, 0, 1, and 2. Well, absolute value of -2 is still +2, so I'm going to do 2 times 2, which is 4. Absolute value of -1 is +1 times 2 is 2. This is still going to be 0. And this is going to be the same as the other side because absolute value of 1 is the same as -1. Absolute value of 2 is the same as -2. So now my points are -2, 4, -1, 2. Oops. That's still 0, 0, so my vertex has not changed. 1, 2, 2, 4. So let's graph that. -2, 4 is right here. -1, 2, we're still at the vertex of 0, 0, and then the right side's the exact same. So the red one is our original parent function, just the absolute value of x. When I added the 2 in front, it looks like it made the v a little bit skinnier. Okay, so it made it a little bit skinnier. So this 2 impacted how steep our v lines are. The domain was not changed though. It's still all real numbers. And the range did not change. My range is still y is greater than or equal to 0. My axis of symmetry is not changed. It's still at 0. My vertex is also still at 0. So not much change. The only thing that changed was how steep these lines are in our graph. Okay. One thing I also want to point out is let's look at the slopes of these lines. The slope of this line right here looks like it goes up 2 over 1, up 2 over 1. And notice how, whoa, that was weird. Notice how we have the number 2 here. The slope of this one's up 1 over 1. And that was for the absolute value of just x. So something just to point out. Okay, so go ahead and try this one on your own. Make your table. Let's do the same values for x. So let's keep it at -2, -1, 0, 1, 2. Fill this out and then graph your points. And then once you unpause it, I'll have the graph there. So you don't have to watch me walk through the process again. But try it on your own. Okay, so your graph should have looked like this. Now the v has been flipped upside down. So this is when we can have negative values because if I plug in -2 here, the absolute value of -2 is still +2, but +2 times -1 is going to give me -2. So that's why now all my values are going to be negative in the end because I'm going to get a positive answer for my absolute value, but then I'm multiplying it by -1 to flip the sign. So my domain has not changed. It's still all real numbers, but now my range has changed. My range is now y has to be less than or greater than 0 because we're flipping the other way. It will never be positive here. So when we have a negative number in front of the absolute value symbols, it's going to flip it around. It's going to flip it upside down. And that'll happen every time. Okay, so recap real quick. The number being multiplied in front made it skinnier. Negative number in front made it upside down. So now we're going to talk about how to interpret some of these absolute value functions and answer some questions from looking. Okay, so here Jay rides in a boat from his home to his friend's house, home in a neighboring state. The graph of the function is this, 30 times the absolute value of t minus 1.5. So now we have stuff going on inside these absolute value symbols, and we'll learn about those a little more later. But this shows the distance of the boat in miles from the state at t hours. Assume the graph shows Jay's entire trip. So this shows his trip right here. So he started, okay, this is distance in miles. So he started, looks like he started, what is it, counting by 5? 45 miles away. 1.5 hours, and then 1.5 hours back, the 40 miles, the 45 miles. So how far does Jay travel to visit his friend? Well, it looks like he had to travel from 45 miles to 0 miles to the house. So that's 45 miles plus an additional 45 miles. So the total distance traveled was 90 miles. That was the total distance he had to travel. Now, what is the rate of change over the interval between t is 2 and t is 2.5? So that's going to be between here and here. So it's asking me, what's my rate of change between here and here? So when we find that interval, it's asking for the x-values. I'm just looking at what's the slope here. So what's the rate of change here in this particular area? Well, this is a straight line, so the rate of change here is going to be the exact same as this from here to here, from here to here. I'm really just looking for the slope of this line. Well, so I'm going up 5, 10, 15. I'm going from 15 to 30 over, and this graph is counting by 2.25, right? I'm going from 2 to 2.5, so that's going to go up 15 over 0.5. So which is 30 over 1. So that means that they were traveling 30 miles per hour. So you might have to look at a certain section of the graph and interpret the rate of change. You might have to also determine what it means in the context of a word problem, like this one where you travel 90 miles. Okay, so Sandy takes a hike on a 6-mile trail. She hikes from the beginning of the trail to the end, and then turns around and follows the trail back. The graph shows her distance from the start of the trail after X hours. How far does Sandy travel on her hike? How long is her hike? Well, again, so this is when she's at the trailhead. She just started. She walked 6 miles away, and then she has to walk 6 miles back. That gives you a total of 12 miles as her hike. And the hike took a total of 4 hours. Okay. Now, let's see here. We have a walkway at an airport. Then 8 seconds after she gets on, she taps Lisa, who's standing alongside the walkway. The graph shows Kata's, we'll call her Kata. Kata's distance from Lisa over time. Calculate the rate of change for distance from Lisa from 6 to 8 seconds, that's from here to here. And then from 8 to 12 seconds, that's from here to here. So we're finding the rate of change. What does the rate of change mean in terms of Kata's movement? Okay, well, this graph's counting by 4s. So it looks like we're going up from this point to this point. So I'm looking at the rate of change from 6 seconds to 8 seconds. Looks like we're going down 4 over 2. So our rate of change was -2. Because down 4 over 2 is -2 feet per 1 second. Well, from 4 to 12, that's going to be here. It looks like we're going up. You can't see that line, but there's supposed to be a line there. Up 12 over 4. Okay, so that's up 12. Let me make sure I'm doing this right. Yep, up 12 over 4, which is 3 feet per second. Okay, so now what I notice here is this line's a little bit steeper than this line. Yes, it shows a V, but this one has a larger steepness to it. So what we figured out is what does the rate of change mean in terms of Kata's movement is that she picks up speed after she gets to her friend Lisa, and then she starts going faster because the line becomes steeper and her rate of change increases. Okay. That's all I got for you guys. So things to remember. Let's just put absolute value of a negative number is always positive. So this reminder, because that's a big one. Okay, guys, I hope this video helped. If you guys have any questions, please let me know. Your D is out.